This is a brief overview of the Accuknox technology roadmap, which includes an ongoing research and technology collaboration with SRI's Computer Science Laboratory and KAIST University. To start, let's first consider one of the fundamental challenges that our roadmap is seeking to address. Robust container security, in a large sense, requires us to redesign security services and policy generation, such that they can be seamlessly orchestrated as a natural part of the DevOps process. To do this, we need the core technology to be much more adaptive, self-learning, and where possible, help automate its configuration toward a least permissive security posture the moment the container moves from development to production. And in fact, we've seen a continual stream of incidents in which the pressure for a competitive DevOps cadence utterly undermines the ability of an organization to secure its critical workloads in the cloud. Here are 4 examples that are strikingly similar and essentially capture this point. There was a lot that went wrong across these examples: poor identity management, no live and scalable container monitoring, poor application constraints enabling direct OS southbound compromises, unbounded inter-container communications that enabled lateral attack propagation, and little if any insight into what data was lost or stolen during these attacks. We intend to re-envision a secure CI/CD process that directly addresses all of these issues. Most critical to our approach is to automate and streamline security service and policy integration into the DevOps process, and to do so with technologies that are designed to be adaptive, self-learning, and that scale well as the container ecosystem expands. In this roadmap overview, we focus on just 4 of the major security services that we intend to seamlessly integrate into CI/CD pipelines, and which work together to produce a zero-trust security posture for every container the moment it reaches production. The Accuknox Workload Identity Manager provides the foundation for establishing trust within a multi-container cloud deployment. Its purpose is to streamline the DevOps team's task in identifying the communications topology among workloads that need to dynamically spawn and interact together. Once defined, the Identity Manager automates cert orchestration and deployment as the production package is instantiated. It employs short-lived SVID certs, allowing us to leverage its automation to simplify rotation and revocation challenges that arise in large, elastic environments. The Accuknox Network Policy Enforcer will help to integrate network policy generation into the CI/CD process and enables the DevOps team to enforce fine-grained, least permissive communication policies per container. Here, the NetSec Enforcer will integrate a topology and inter-container dependency discovery algorithm that was created by KAIST and SRI, which we presented at the 2020 Usenix ATC conference. The policy generator essentially gives the DevOps team an immediate leg up with a default zero-trust security policy tuned for the container topology, and which can be customized by the DevOps team as needed. Our algorithm can also auto-detect and generate missing network communication policies and recognize excessively permissive policies that are defined but not employed at runtime. The Accuknox Forensic Optimizer introduces an entirely new container-unique strategy for scaling the collection, storage, and analysis of container internal application forensics. It introduces a deep learning method called variational autoencoders, which it uses to construct a per-container model of operational stability. Using the VAE's stability metric, live container forensics are cached and at regular intervals are evaluated to determine if the container is operating in a known stable manner based on how the VAE was trained. At each stable operating interval, the VAE reports a low-dimensional model M that summarizes the activity that occurred during that interval. When non-stable, or when other security alerts or policy indicators are observed, the VAE will then publish both the model and the forensic records for that interval. This strategy of reducing the forensics to M and reporting M when the container is stable provides a massive overhead reduction in forensic transmission and in the backend storage, while providing an equivalent forensic reconstruction fidelity when failures or anomalous operations are detected within the container. We believe this approach is a game changer, enabling one of the first viable strategies for app layer forensic collection, particularly when a container is replicated at very high numbers. Our third security service is the Accuknox Dataflow-Tracking Provenance engine, which, as it sounds, will integrate an ability to track sensitive data as it is processed, stored, and transmitted across a container cluster. To do this, we will introduce a container-aware runtime monitoring service, which can track sensitive data flows through a novel eBPF-based data provenance algorithm. This service, based on more than a decade of data provenance research at SRI, will enable a unique and fine-grained ability to impose data-centric security policies within containers and across a multi-host, multi-container pipeline. The Accuknox Security Orchestrator will facilitate seamless CI/CD integration of all of our security and policy enforcement services. From our orchestrator, the DevOps team can enable workload identity management, which provides the foundation for our trust boundary, generate and refine a baseline least permissive network security policy, and then manage its deployment, define application-specific runtime policies to limit subversion and prevent unwanted app behavior, initiate an optimized and scalable form of live forensic auditing and live container stability monitoring, track all sensitive data as it flows within and across the container cluster, and monitor and enforce the spectrum of security compliance requirements that must be commonly addressed in production deployments. Finally, I stated earlier that our objective is to integrate Accuknox into the CI/CD process such that we can streamline the production of zero-trust security postures for every container the moment it reaches production. Solutions like ours are essential now, particularly in ecosystems that face stringent security compliance standards in order to operate. Let's take a look at how the Accuknox roadmap can provide a comprehensive protection of the applications, data, user permissions, communication policies, and forensic monitoring requirements to help automate compliance satisfaction. The table here shows requirements from the PCI DSS security standard, with the exception of those requirements involving personnel and procedural practices. The table shows the mapping of the Accuknox security services that directly addresses each of the PCI DSS security compliance requirements. Through our security orchestrator, you'll be able to configure your package to address these requirements and those that exist in other compliance standards. As we pursue our roadmap, we intend to bring together quite a few unique and differentiated techniques, all of which will blend to facilitate our ability to reimagine a secure CI/CD process. Here is a view of the Accuknox technology stack and its integration into the continually evolving broader ecosystem of container management services. And that's a quick overview of our technology roadmap. Thanks for your interest.